Today's lesson we are going to look at transformers. So first of all, what is a transformer? A transformer is made up of an iron core with a loop of wire on one side, which we call a primary coil, and another loop of wire on the second side, which we call a secondary coil. Transformers have the ability or are used for changing the size of voltages in a circuit. They use electromagnetic induction to do this, and they can be either step-up or step-down transformers. If you are unfamiliar with electromagnetic induction, please watch the previous video. For this is a step-up transformer. And the main question here is, how do we know that it is a step-up transformer? Step-up transformers have more coils on the secondary side compared to that of the primary. So if we count the number of coils, you can see that there's 5 on the primary, whereas on the secondary there is 8. Step-up transformers increase the voltages from one coil to another. So because it has a greater number of coils, the voltage will increase from the primary to the secondary. And we are going to look at how does a transformer increase the voltage from one coil to another. Again, we will draw our diagram. This time it is key to note that an alternating current moves through the primary coil. It generates a magnetic field through the iron core. It is key that we use an alternating current because a direct current will not work for transformers. Because of the alternating current, the magnetic field constantly changes direction. So the alternating current will change direction and the magnetic field will change direction, back and forth all the time. This changing of magnetic field induces an alternating voltage on the secondary coil. However, as the secondary coil has a greater number of loops, this voltage will be greater. When we're talking about step-down transformers, it is the opposite, as they have more coils in the primary compared to that of the secondary coil. And because of this, because of the reduced number of coils, the voltage will decrease across the transformer. From this, we can calculate the output voltage of a transformer. And to do this, we need the following formula. So, voltage across the primary coil, Vp, divided by voltage across the secondary coil, Vs, is equal to the number of turns or coils in the primary coil, so that will be Np, divided by the number of turns in the secondary coil, which would be Ns. So Vp divided by Vs is equal to Np divided by Ns. Or it can also be rearranged as Vs divided by Vp equals Ns divided by Np. These formulas are used interchangeably and they are both the same. So you can write the formula either way. However, if I was using this formula, you should always put the thing you are trying to find out or trying to figure out on the top. So if we're trying to find Vp, we'd use the first formula. If we're trying to find Vs, the second formula, and so on. So I'm going to give you an example. I would ask you to maybe read through this example and take a minute pause on the video and try and calculate it yourself. So the question states, a transformer has 40 turns on the primary and 800 on the secondary. If the input voltage is 1000 volts, find the output voltage. So take a pause in the video now and have a go at answering these questions. Now that you have had a go at answering the questions, I'm going to go through exactly how you should answer this question. First thing, always write your formula. So Vs divided by Vp equals Ns divided by Np. Second thing you should do, try and figure out what you have and what you don't have. A diagram can be helpful for this. So, VS, VP, NS, NP. Well, we were told that 40 turns were on the primary, so that's NP. We were told that 800 turns were on the secondary, so that's NS. And we were told that the input voltage, so the voltage on the primary, was 1000 volts. So we were trying to find out the output voltage, VS. Next thing you should do is rearrange your formula. So VS is equal to NS divided by NP multiplied by VP, because we're trying to figure out VS. Once we have arranged our formula, submit in your values, and this works out to be 20,000 volts. And the fifth and final stage is to include your unit. Always include your unit. So for this, it was volts. So where do we use transformers? Transformers are used in the national grid and help us with the generation of electricity. So for here, X is labelled a step-up transformer and Y is labelled a step-down transformer. There's a key note that we should take into consideration here. When current flows through a wire, some energy is lost as heat. The higher the current, the more energy that will be lost. So, to stop this, step-up transformers allow electricity to be transported at high voltages, yet low currents. This is to reduce energy loss. So a usual power grid or power station will generate 25,000 volts. However, the step-up transformer will convert this 24,000 volts into 1,300 or 132,000 volts, or even 275,000 volts, or 400,000 volts, depending on the power grid used. These higher voltages are too dangerous, however, for use in our homes. So step-down transformers are used locally to convert these or to reduce the voltages to safer levels that they can be used at home. Hopefully this will help with your knowledge of transformers.